Hey everyone, and welcome to this explainer. Today, we're unpacking the architecture of cloud networking. We're going to do this by looking through the lens of a brilliant senior software engineer named Margaret and her junior colleague Timothy. Picture them sitting in this grand Victorian library in London, talking shop about the tools powering modern software. We get to be a fly on the wall for a genuinely crucial lesson: why just drawing boxes on a whiteboard is never, ever enough when you're designing cloud infrastructure.
So let's dive right into this massive realization Timothy had. He brought Margaret this beautiful, careful pencil diagram of his cloud architecture. EC2 instances, an S3 bucket, a database, all connected with neat little arrows. But here's the catch. Drawing boxes for services just isn't enough, because the cloud actually has an address. That unnamed blank space between his perfectly drawn services, totally ignored. And as Margaret so wisely points out, most developers don't even think about that invisible space until the network actively stops them in their tracks. Okay, to fix this, we're going to use Margaret's incredibly helpful blueprint metaphor to construct your networking knowledge step by step. Our agenda today: first, the missing network; second, building the VPC; third, public and private subnets; fourth, gateways and traffic flow; fifth, 2 layers of security; and finally, moving beyond the default. Let's get right into it. Section 1, the missing network. Let's look at how this all builds up, focusing right on that blank space Timothy completely missed. You see, Timothy actually mapped out his services perfectly. He knew exactly what region they lived in and how they logically connected. But as Margaret pointed out, he completely forgot the absolute foundation, the network holding it all together. And here's the reality. The decisions you make, or honestly, the decisions you fail to make about that underlying network, completely dictate the limits of your architecture. Simply put, if you don't define the network is going to define you. Moving on to Section 2, building the VPC. This is where we hit the absolute bedrock of AWS networking. So what exactly is a VPC? A virtual private cloud is basically your own private, fenced-off territory inside AWS. It's logically isolated from every other customer's stuff. When you create a VPC, you are carving out a very specific block of IP addresses that belong entirely to you. And this is the kicker. Literally nothing outside this specific block can reach inside unless you explicitly say so. Every single resource you spin up gets an address right from this private pool. I really love Margaret's building metaphor here because it perfectly visualizes the concept. Think of the VPC as the physical, enclosed walls of a brand new building. Right now, it's just the walls. No doors, no windows. The building is there, it's structurally sound, but it's totally sealed off. Absolutely nothing gets in or out until you, the architect, actually decide to cut out a door. All right, Section 3, public and private subnets. Now we're going to take our massive empty building and break it down into functional individual rooms. The difference between public and private subnets is absolutely crucial. Think of them as the rooms inside our building. A subnet is just a smaller chunk of addresses inside your VPC where you put your stuff. Public subnets, those are the rooms facing the street. They have a direct route to the internet, so things inside can actually be reached from the outside world. But private subnets, those are your internal windowless rooms. No route to the internet whatsoever. I mean, think about it. You would never, ever put your most sensitive assets, like a customer database, in a room with a big glass window facing a busy public street, right?
So laying out your rooms this way creates what we call a defense-in-depth architecture. It works like this. You put your load balancer in a public subnet because, well, it has to talk to the internet. Then you tuck your application servers safely away in a private subnet where they only take traffic from the load balancer. Finally, your database goes into the deepest, most isolated private subnet, only talking to the app servers. This way, if an attacker somehow breaches the public load balancer, they still have to battle through multiple layers of internal security just to get anywhere near your private data. Which brings us to Section 4, gateways and traffic flow. How do those internal, locked-away resources actually talk to the outside world when they need to?
Well, for our public subnets, those street-facing rooms, we use an internet gateway. It is exactly what it sounds like, a literal front door between your VPC and the public internet. This door lets traffic flow in both directions, allowing your public resources to talk to users and the web. But remember, while public subnets use this two-way door, our private internal rooms need a totally different solution. Because what happens when an internal server needs to download a software update or call an external API? You can't just open a two-way door and risk letting attackers sneak right in.
That is exactly where the NAT gateway comes in. Network Address Translation. So picture this traffic flow. Your deeply private resource needs something, so it initiates an outbound request. That request routes through the NAT gateway, which we've carefully placed securely in the public subnet. From there, the traffic safely exits through the internet gateway. It's brilliant, actually. The NAT gateway allows your internal server to reach out to the world, but it actively, completely blocks the world from initiating a connection back in. Outbound is totally fine. Inbound is a hard no. But hold on a second, I need to share a massive operational warning from Margaret here. NAT gateways are managed services, and they are not free. They run on a meter, literally billed by the hour and by the gigabyte of data processed. Forgetting to tear down a NAT gateway in a casual dev or test environment is a shockingly fast way to wake up to a massive AWS bill. It's a perfect reminder that mastering cloud networking isn't just about locking things down securely, it's also about keeping your wallet safe.
All right, Section 5, 2 layers of security. We've built our walls and our doors, but how exactly do we lock them?
If the subnets are the rooms of your building, how do you manage the locks on the individual doors? AWS actually gives you 2 distinct tools to control this network traffic. And since networking issues are notoriously binary, the traffic either arrives or it doesn't, troubleshooting means methodically checking both of these mechanisms to figure out what is blocking you.
Okay, this is absolutely crucial to understand. The difference between security groups and network access control lists, or NACLs. NACLs operate at the broader subnet level. They are stateless, which means you have to explicitly write a rule for traffic going in and a separate rule for traffic going out. Think of the NACL as the security gate at the main entrance to the room itself. Security groups, on the other hand, operate right at the individual resource level, like an EC2 instance. These are stateful. If you allow a request in, the response is automatically allowed back out. Think of the security group as the actual physical lock on a specific door inside that room. So inbound traffic hits the stateless subnet gate first. If it makes it past that gate, it still needs the exact right key for the stateful security group lock on the resource's door. Make sense?
Now, for our final section, Section 6, moving beyond the default. We've got our blueprint, so let's talk about the default network AWS hands you on day one and why Margaret strongly says you need to ditch it immediately.
Look, every single AWS account comes with the default VPC. It's explicitly designed to remove early friction. It is perfectly fine if you're just spinning up a quick tutorial or a Sunday afternoon dev test. But the fatal flaw? It chucks absolutely everything into public subnets. The default VPC takes all those brilliant layered defenses we just talked about and collapses them into one giant street-facing public room. Relying on this for production is just kicking the can down the road on a critical architectural decision. And believe me, it will cost you dearly when you're suddenly dealing with real sensitive user data. On the flip side, building a custom production VPC, it requires maybe 1 hour of design time up front to set up minimal security rules and properly layered private subnets. That 1 hour will save you a world of pain later. After absorbing all of this, Timothy had this total light bulb moment. He literally flipped his paper over and completely redrew his diagram. But this time, he didn't start with the services. He drew the VPC first. Then he carved out the public and private subnets, tucking his databases deep inside the private ones, and carefully mapped out his gateways. He finally put the network foundation exactly where it belongs, first, instead of treating it like some annoying afterthought. So as we wrap up this explainer, I really want to leave you with a question to chew on. When you go back to look at your own cloud infrastructure today, take a hard look at your blueprint. Have you truly, intentionally designed your network's walls, your doors, and your locks? Are you actively controlling your environment? Or are you just blindly drawing boxes and waiting for the network to aggressively stop you? Take that hour to design your foundation the right way. I promise you your future self is going to thank you for it.